So let us go back to elementary calculus and consider the following function. Is it increasing? Is it decreasing? So remember that you can take the derivative of this function. And here, again, recall that if you have f divided by g, and you're taking the derivative, it is f prime g minus f g prime divided by g squared. So the derivative of this function is the derivative of x, which is 1, times x squared plus 1, minus the derivative of x squared plus 1, which is 2x, times x divided by x squared plus 1 to the second power. So the derivative of the function is basically x squared plus 1 minus 2x squared divided by x squared plus 1 to the second power, which is 1 minus x squared divided by x squared plus 1 to the second power. So the denominator is always positive. This guy has nothing to do with the sign of the derivative, always positive. So since this guy is always positive, it doesn't play any important role in analyzing the sign of the derivative. For the sign of the derivative, you have 1 minus x squared. So what is 1 minus x squared? 1 minus x squared is a quadratic function. Well, if you set it equal to 0, it passes the graph at negative 1 and 1, and if x is equal to 0, it is 1. So the behavior of the 1 minus x squared is like this. So what's the meaning of the sign of 1 minus x squared? The sign of 1 minus x squared is where your y value is positive or negative. If x is bounded between negative 1 and 1, so let's just write it here, bounded between negative 1 and 1, then y, or 1 minus x squared, is above x-axis. It is positive. So f prime is going to be positive on the interval negative 1 and 1. Is positive on negative 1 and positive 1 on this little interval. For the rest, the graph is below x-axis, but the graph is in the negative part of y-axis. So is negative or decreasing on negative infinity to negative 1, union 1 to positive infinity. You can use Desmos and graph this function and check the behavior of this function. Where is it increasing or where is it decreasing? Since f prime is positive on negative 1 to 1, the original function f of x is increasing on negative 1 to 1. And since the derivative is negative on negative infinity to negative 1, union to 1 to infinity, the original function is decreasing on these two intervals. So f of x is decreasing on negative infinity to negative 1, union 1 to positive infinity. So if I give you, for example, a sequence like f of n equals to n over n squared plus 1, and I ask you to analyze this, is it an increasing sequence or decreasing sequence? You can basically convert this back to a function in x, analyze the function, and use those conclusions and result for your sequence. So you're going to say that, hey, f of n is increasing on negative 1